All right, so this is just a little Maple demonstration to show you how you can plot some of the things that we've been learning about in Maple. And I wanted to work through example 4, which was on page 21 of your course pack in the notes from section 11.7. So I'm going to start out in my new Maple document, and I'm going to plot, so I need with plots. And I'm going to be working with vectors. So let's do with vector calculus. Oops, I think that has to be a capital. All right. First of all, I'd like to find actually plot the actual trajectory itself. And that was the position equation that was given to me. Eventually, I'd like to refer back to these plots so that I can get them all on the same graph. And so I'm going to go ahead and assign the name R. So R colon equals, and that's just going to be the space curve for my trajectory, which was t plus 3, t squared, 2t cubed. I'll plot that from t equals, let's say, 0 to 4 seconds. And let's do axes equal normal, and let's plot it in red. All right, so there's my space curve. This is actually a little bit better perspective than the one I had in your course pack. If you look at this, you can see right around here we have x equals 4 and y equals 2. So right around that point is the point that we were trying to plot the velocity and position vectors. Let's see if we can do those. Now here's the problem. If I just ask Maple to plot a vector, it's automatically going to plot that vector starting from the origin, that is in standard position. And we'd kind of like to see these vectors plotted at the point 4, 1, 2, the point we were at time 1. So in order to do that, I'm going to have to create what's called a rooted vector, which means I'm going to create a new vector space. And I'm going to tell Maple what the starting point for that new vector space is. You can name your vector space anything you want. I'm just going to name it VS for vector space. And I'm going to define my vector space as vector space. That's the command. I need to tell it what kind of system I'm in. It's Cartesian coordinates, not polar or something like that. So in little quotes there, Cartesian. And then I'm going to tell it what is the starting point for my vectors. I'll put them in brackets, 4, 1, 2. That was our R1. That's the position we were at time 1. So that's going to define the vector space. It's going to say something kind of weird. Don't worry about that. It's just executing that command, and we shouldn't be seeing anything special right now. All right, we're now ready to plot the vectors that we want in this vector space that'll start all the vectors from 4, 1, 2. So let's define the velocity vector. V colon equals for the velocity vector. And I like it to be a vector plot, so I'm going to tell it to plot the vector. And this is where I tell it to work within the vector space that I just defined, the one that starts at 4, 1, 2. I called that vector space VS, colon, and you have to use a little minus sign here, so colon minus. That's essentially the notation that Maple uses. And then I want it to plot the vector, and you're going to need both a parentheses and a bracket here. And then just type in your velocity vector. In our case, our velocity vector was 1, 2, 6. Bracket, parenthesis. Okay. It's going to plot just that vector right now. So I'm going to go, whoops, what did I do here? I missed something. Oh, sorry, I have 2 starting parentheses and only 1 ending parenthesis. Unable to match delimiters usually means that you've got your parentheses off. There we go. So there's our velocity vector just sort of plotted in isolation. If you turn it a bit, you can see there's 2 and 4. You can see the position that it starts at is not the origin. Let's define the acceleration vector the same way. So a colon equals. And my acceleration vector, again, I want it to plot the vector in my vector space VS, colon minus, again, just maple notation. And it's the vector, parentheses and brackets, and it was 0 to 12. Bracket parenthesis, and then end my initial parentheses, and there we go. So there's our acceleration vector. Again, you'll notice that it definitely doesn't start at the origin. So it's started in our new vector space. Okay, what I'd really like to see is all 3 of these things plotted in the same axes. So I'm now going to use the display command, and I want it to display my space curve R along with my vector V and my acceleration vector A. So there's the space curve, the velocity vector, and the acceleration vector. And here we go. We should have them all. Yeah, they're a little bit small, but we can kind of see them here. So you can see right at this point, we've got our velocity vector that's just tangent to our curve here. And then we've got our acceleration vector going up this way. So I can see everything plotted on the same axes with my vector starting at the position at time 1. All right, we will stop there, but that just shows you how to plot a curve with some vectors on it.